Today in MATLAB Basics, we're going to cover a variety of functions that center around the use of polynomials in MATLAB. You can see here that we've started out with a polynomial x squared minus 0.5x minus 0.5 and gotten a simple plot of it going from minus 2 to 2 on the x-axis. Next, what we'll do in this example is we're going to add some normally distributed random noise on top of that y data, and then we're going to take that new set of data and try and fit a polynomial back to it, shown here in red, and compare how these look to one another. Alright, let's get started here. First, I'm going to need some coefficients, so I'll type those out, and that's going to be the coefficients of my polynomial. Next, I'm going to want to make a linearly spaced vector that goes from minus 2 to 2. If I look at whose, I can see I have those two variables in my workspace. Next, I want to know what the polynomial values are for y. So I'm going to say y equals polyval of coefficients and x. And so now I should have the correct y values for that polynomial. Let's try and find out. Plot x comma y. And that looks pretty good. I like to keep my axes equal, so let me do that also. There we go. That looks more realistic. Next thing I want to do is this polynomial seems to be crossing the y equals 0 at 2 points. We zoom in here. We can estimate what those are at about negative 0.5 and at about 1. So how can I find those out for real? Well, if I say roots of coefficient, it's going to go through and calculate those, and it's what I estimated. So we've got that right. Next, I wanted to add some noise to this polynomial. So I'm going to say noise is equal to rand n. And how much noise do I want? Well, I want it to be the size of y. And I don't want it to be the full normal distribution that tends to go from minus 1 to 1. I'd like to tone that down a little. So I'm going to multiply by a gain of 0.2. Excellent. Now I'm going to make a new y vector, y noisy, which is going to be equal to y plus the noise. And I'm going to turn hold on and then say plot x comma y noisy, like this. And I'll put that in green so I know what it is. And there we are. We can see the noisy polynomial. Next, I want to fit a polynomial to this noisy data. So I'm going to say that the fit coefficients are going to be equal to poly fit of x and y noisy. And I want a second degree polynomial, so that would have an x squared in it. And that's going to come out like this. Let's compare that to the original coefficients before the noise, and you can see that they're very close. So I think the polynomial fitting is doing very well, considering the fact that it is a noisy signal. Finally, I want to know what the polynomial to these new coefficients looks like. So I'm going to call that fit y is equal to polyval of the fit coefficients. And again, I will put in x there. Oops, I forgot the semicolon, so it shows all of that for me. And finally, let's say plot x comma fit y. And I want red this time. There we are. We can see that the red and blue line are almost identical on top of one another. So this is a good fit. Thank you.